Another type of problem in graphing transformation is in this example. Describe the transformations applied to the basic function f of x equal to absolute value of x to obtain the function g of x equal to negative absolute value of x minus 1 plus 2. Comparing this function to this parent function, you can see a transformation of 1 unit to the right and reflection about the x-axis and vertical shift 2 units upward. So if we will write the order of the transformation, we will be starting on this first term. For this first term, we will start with horizontal shift. So this is the first transformation. And then second is reflection. And then the third is the vertical shift. So if we will write the transformation, so the graph is shifted 1 unit to the right because the x is replaced by x minus 1. And then in this function of y, it's multiplied by a negative. So multiplying negative in y, the next transformation is reflect about x-axis. And then the last transformation is shifting vertically 2 units upward. So then shift 2 units upward. So there is another option in this transformation that we can describe. So for example, so on option 2, so we have a g of x equal to negative absolute value of x minus 1 added by 2. So in this first term, we can also start by reflection, and then after that, replacing x by x minus 1, so it's horizontal shift, and then the last one is the vertical shift. So if we will write the transformation, so this is shift or reflected about x-axis, and then shifted horizontally 1 unit to the right, and then shifted 2 units upward. So these are the two possible description on the graphing transformation. For this example, we will find the function in simplest form that is finally graphed after the series of transformations are applied to the graph of the function square root of x plus 1. So the series of transformations are reflect about the y-axis, then shift left 2 units and 3 units up, then reflect about the x-axis. So starting from this function, square root of x plus 1, if we will reflect about the y-axis, then the effect in the function is we will multiply negative 1 in x. So the function will give us f of x is equal to square root of x plus 1. So multiplying negative in x, so we will put the negative in the x. Then after that, based from this function, we will then shift left 2 units and 3 units up. So when we shift left 2 units, we have to replace x by x plus 2. And then when we say we have to shift 3 units up, we will add 3 in the function y. So the effect on the function based from this, we will have f of x is equal to square root of negative x plus 1. Since we are replacing this x by x plus 2, so we will then change this with x plus 2, then plus 1. So this is When we shift left 2 units, we are replacing x by x plus 2. So we replace this x with x plus 2. Then after that, this is the function y. We will add 3 in this function y. So we will then add 3. Then let us simplify this function first before we continue. So this is equal to square root of negative x minus 2 plus 1, because we will distribute this negative in x plus 2 to get negative x minus 2. Then after that, we will add 3. To further simplify, we can combine like terms like negative 2 plus 1 inside the root. So square root of negative x minus 1 plus 3. So this is your function in this transformation. Then we will then transform this by reflecting about the x-axis. When we say reflect about the x-axis, we will multiply negative 1 in y. The y function is this. There are two terms of function y. So it means to say the transformation will be f of x is equal to multiplying negative in square root of negative x minus 1 and multiplying negative in 3, so it will give us negative 3. So it means to say we multiply negative in these two terms. So this is square root of negative x minus 1 will be negative of this square root, and then this plus 3 will be minus 3. So this is the final function after the series of transformation. That is the end of this video. If you find this video useful, please like and subscribe and turn on the notification bell so you never miss out on the future content.